A 35 billion parameter local model just scored higher than Claude Opus 4.6 on one of the hardest coding benchmarks, and only around 3 billion of its parameters are active at a time. This is Ornith 1.5 35B-A3B. On SWE-bench Pro, it finishes more than 6 points above Opus and just behind Qwen 3.8 27B. But this model is interesting for more than one benchmark. Ornith was trained with a system that creates new coding tasks, builds the tools needed to solve them, and learns from the results. In this video, we'll compare Ornith with Qwen 3.8 27B and Claude Opus 4.6. We'll look at how it reached this level and whether it is actually useful for real coding work. Then I'll show you how you can run it with a 6GB GPU and system RAM, or on an Apple Silicon Mac. Because the benchmark results look impressive, now we need to find out whether Ornith is really the local coding model people think it is. Let's start with the biggest result. On SWE-bench Pro, the order looks like this. Claude Opus 4.6 scores 53.4, Ornith scores 59.6, and Qwen 3.8 27B scores 61.7. That puts Ornith directly between Opus and Qwen. SWE-bench Pro is not a simple test where the model writes a short function. The model works inside real software projects. It has to find the problem, inspect different files, change the correct code, and produce a working solution. In other words, it tests whether a model can behave more like a coding agent and less like a chatbot. And on this test, Ornith scores more than 6 points above Opus 4.6. Anthropic has never revealed the size of Opus, but it is probably more than 50 times larger than Ornith. That does not mean Ornith is now better than Opus at everything. The order changes on other coding tests. On SWE-bench Verified, Ornith scores 79, while Opus scores 80.8. On the multilingual version, Opus also stays ahead. So the real result is not that Ornith has completely replaced Opus. The important part is that a small local model is now competing in the same range on difficult software engineering tasks. Its comparison with Qwen is even closer. Qwen leads Ornith by only 2 points on SWE-bench Pro. On Terminal Bench, Qwen scores 73, while Ornith reaches 68.5 with Claude Code. This test is more focused on long terminal tasks. The model has to use tools, react to errors, and keep working until the job is finished. Here, Qwen has a clearer lead, so based on the published results, Qwen 3.8 27B is still the stronger coding model overall, but Ornith is much closer than its size would suggest. One detail is important here. These results do not all use exactly the same agent setup. The harness, tools, and time limits can change the final score. So the numbers show that Ornith has serious potential, but a real comparison still needs the same projects and the same tools. Even with that in mind, getting this close to Qwen is impressive. Now the next question is simple. How can a model with only around 3 billion active parameters perform this well? Ornith 35B-A3B is a mixture of experts model. That sounds complicated, but the basic idea is simple. The model has around 35 billion parameters in total, but it does not use all of them for every token. Instead, it selects a smaller group of parameters for the current task. Only around 3 billion are active at once. Think of it as a large team with different specialists. The whole team is available, but only the people needed for the current job start working. This can reduce the amount of compute needed to generate each token. But it does not mean the model only needs as much memory as a 3B model. All 35 billion parameters still need to be stored somewhere. They can stay in GPU memory, system RAM, Apple Unified memory, or be split between them. That difference is very important. Ornith may be light on compute, but it is not a tiny model. This is also why it can be interesting for computers with a weaker GPU but plenty of system RAM. The machine still has enough space to store the model. And because only a small part works on each token, generation may be more practical than running a dense 35B model. But the architecture alone does not explain the coding results. The bigger reason may be the way Ornith was trained. Most models learn from tasks collected or prepared by people. Developers choose the problem, give the model tools, run the test, and use the result for training. Ornith 1.5 adds another step. It helps create the tasks too. Imagine that the model can already fix a simple bug in one file. Giving it the same type of bug again will not teach it much. So the system creates a harder task. Maybe the next bug is spread across several files. Maybe the model needs to run tests, understand an error, and change its plan. The task should be difficult, but still possible. If it is too easy, the model learns very little. If it is impossible, there is no successful solution to learn from. Ornith tries to find the space between those two. It creates a task near the limit of what the model can currently solve. Then it builds a setup for that task. This setup includes the instructions, the tools, and the steps the model can use. Ornith tries to solve the problem, and the system checks whether the result works. That result is then used for more training. As the model improves, the old tasks become too easy, so it creates new and harder ones. The basic loop is simple. Find a weakness. Create a useful task around it. Try to solve it. Check the result. Then create a harder task. This may be why Ornith performs well on agentic coding tests. It was not only trained to produce a good first answer, it was trained to keep working through a problem. That includes using tools, dealing with errors, and trying a different plan when the first one fails. Ornith also supports reasoning, tool calling, and a native context window of roughly 260,000 tokens. It can understand images as well, although most of the published results focus on text, coding, and agentic work. Qwen still has a more complete multimodal system, especially with its clear support for both images and long videos. But for coding, that may not matter to every user. The more important question is whether Ornith can run on the hardware you already own. Yes, but there is an important condition. The model does not fit inside 6 GB of VRAM. You need to keep part of it in system RAM. The official Q4 version is 21.7 GB. For most local users, this is the best version to start with. It is much smaller than the full model while keeping a reasonable level of quality. If you have a 6 GB GPU and 32 GB of RAM, you should be able to load the Q4 version. Part of the model can run from the GPU. The rest stays in system RAM. This will not be as fast as keeping the whole model on a large graphics card. You may also need to use a smaller context window. But it makes the model available to people who do not own an expensive GPU. With 48 GB of RAM, the setup becomes much more comfortable. There is more space for the model, the operating system, and the context. This should be a better option for cards like the RTX 2060 with 6 GB of VRAM. If you have a 16 or 24 GB GPU, you can move much more of the model onto the graphics card. That should improve speed, while the remaining weights stay in RAM. But do not look only at the file size. The app and the context also need memory. Trying to load the model and use the full context at the same time will require much more memory. For Apple Silicon, the situation is slightly different because the CPU and GPU share the same memory. A Mac with 24 GB of unified memory will be very tight with the official Q4 model. A smaller community quant will probably make more sense. A 32 GB Mac is a much better target for Q4. And a 64 GB Mac gives you enough space to try higher quality versions and longer contexts. The model is still new, so we do not have enough reliable speed results for all these systems. Speed will change depending on your GPU, memory bandwidth, quant, context length, and how much of the model is placed on the GPU. If you want me to test a specific configuration, write your GPU, RAM, and operating system in the comments. I'll use the most common setups in the full local test. The easiest option is the official Q4 version through Ollama. You can download and start it with one command. You can also use llama.cpp. This creates a local server on your computer. You can use it as a normal chatbot, but that would miss the main reason this model is interesting. Ornith is designed for tools and agentic work, so it makes more sense to connect the local server to a coding agent. The official model page includes examples for OpenCode, Pi, Hermes, and other tools. You can also connect it to any coding app that supports a local OpenAI-compatible endpoint. More powerful systems can use VLLM or SGLang. Mac users also have an official MLX version, but the agent around the model can make a big difference. The same model may perform very differently depending on the tools, instructions, and workflow it receives. This is why benchmark scores should not be the final answer. The real test is giving Ornith and Qwen the same project, the same tools, and the same amount of time. So which model should you choose? For most users, Qwen 3.8 27B is still the safer option. It leads Ornith on the main coding results. It has a larger community and more real-world testing. It also has stronger and better documented support for images and video. If you want one local model for coding, general questions, images, and other tasks, Qwen is the more complete choice. Ornith is more specialized. It gets close to Qwen in coding while activating only around 3 billion parameters at a time. That makes it especially interesting if you have plenty of RAM, but limited GPU power. It may also be a better match if your main goal is building a local coding agent and you do not need all of Qwen's extra features. So Ornith has not replaced Qwen, and one benchmark does not make it better than Opus at everything, but that is not what makes this release exciting. A 35B local model with only 3B active parameters has entered the same coding range as models that require far more compute. It is not the clear winner, but it may offer the best balance between coding quality, active compute, and local control for some users. Now we need to see whether that balance survives outside the benchmark charts. I'll test Ornith and Qwen 3.8 on the same real coding projects, using the same agent setup and the same hardware. If you want to see which model actually performs better, leave a like and subscribe.